case, and we said that ambiguous meant unclear. So when we have what we named the donkey theorem, you can see that I did not call it a bad name here. It was SSA, just to be a little bit nicer. This is grade 11. Okay. When we're solving a triangle and you are given the side measures of two sides and an angle opposite one of those sides, I'll show you the triangle again. So you have two sides, then an angle, and that angle is opposite one of those sides that are given. There produces three possible outcomes. What were the three? We watched that video, right? One was two triangles. Oh, I think I want that one here. So we're going to start with no triangle exists that has the given measures. There is what we call no ambiguity. Meaning we don't, remember, ambiguous means you're unclear about something. So the ambiguity comes when you have those two triangles because you don't know if they mean this triangle or they mean the bigger triangle. So the other one was one triangle exists. Again, there's no ambiguity. You know what the triangle looks like. Okay. The third is two triangles exist. There is ambiguity, or this is the ambiguous case. All these big words we're doing today. This is called the ambiguous case. So you need a protractor and a ruler. Okay, so what we're going to do here is the first thing we need to do is, oh, I pre-measured, I didn't even see that down there. I pre-measured a 30-degree angle. Can you verify that? You did. Okay, good. So now what we're going to do is we're going to draw B as 6 centimeters and C as 8 centimeters. So triangle ABC, it's up to you. Let's agree that we're going to make B in the right way here. So does everybody see that little c has to, because this is angle A, little c has to be the one that's opposite angle C, right? So B, we're either going to designate the top or the bottom. Which one do you want to do? The top? Okay, so we're going to take our ruler. So I guess we didn't need a protractor. Sorry about that. And I'm just going to take my ruler and measure 8 centimeters. So mine's going to be obviously a little bit different because my ruler is just kind of generic. Okay, so this is B equals, oh, sorry, 6 centimeters. 6 centimeters. B is supposed to be 6 centimeters. Is 6 centimeters. Okay, did everybody make B 6 centimeters? Okay, so now we're going to draw an 8 centimeter C, which is the opposite of C. So what we need to do is move this, so this is the end, and you see where 8 centimeters is. Where would we have to put this? We'd have to be putting it somewhere there. But before we can do that, we need to actually extend A, because otherwise this won't work. We don't know where it hits, right? So do me a favor and extend A for you don't know how long. Just extend it. Okay? So now let's go back to this corner and measure 8 and see where it actually hits that A. Looks like it hits right there. Everybody get that? 8. So C equals 8 centimeters. Now we're going to measure what A is. I'm sorry? Little a. What'd you get? Centimeters. 12 point. Okay, I'm gonna have to go by what you guys got. 12.6? Can anybody verify 12.6? You got 13. Okay, so I'm gonna say A is 12.6 centimeters roughly. Huh? What'd you get? Okay, I guess the question to you is there an ambiguity? I know there might be an ambiguity whether it's 12.6 or not, but is everybody's triangle pretty much the same triangle? Yeah. So therefore there is one triangle possible. No ambiguity. No matter how I swing this C, there's only one possible way where that C can land and make a triangle. Does everybody agree? This is what it looks like. Okay, so now let's actually set up the sine law. So we get, because we say we want to know what B is, right? Sine of C would be 30 degrees over 8. Does everybody see what I'm doing? Equals sine of B over 6. Yes? We did this for homework yesterday. We're going to cross multiply this over, and we're going to get sine B equals 6 times sine of 30 degrees divided by 8. And actually, we don't even need our calculator because we know what sine of 30 degrees is, don't we? What is it? It's a half. It's a half. So what's 6 times a half? What's 6 times a half? 3. So what do we get sine B to be? Sine B is 3 over 8. We're just going to leave it like that. I want the ratio because the ratio is what's going to actually tell me things. Okay, so we're just going to leave this and we're going to go to the next case. And again, I pre-made 30 degrees. You can verify that. Actually, I want to, maybe I should have wrote that in here. Verify 30 degrees by using your protractor. Does everybody agree this is 30 degrees? Yeah? Okay, so this time B is 10. I didn't put the units, sorry about that. It should be 10 centimeters. And C is 4 centimeters. So again, we need to extend A. So that's the first thing I'm going to do. Actually, I don't need a protractor. Oops. I'll just move it out of the way. I don't need it. Okay, let's extend A, sorry. Extend A, no, we don't know what the length of A is going to be. Let's just extend A. Okay. Then we're going to measure B for 10 centimeters. So, can everybody measure 10 centimeters for B? Yes? So B equals 10 centimeters. Now from that place where it's 10 centimeters, we're going to measure 4 centimeters to get the opposite here. So I'm going to move this. And 4 centimeters. I'm going to swing this, and you notice when I swing this, it never hits A. Do you see that? The 4 centimeters never touches A. Does not. I'm just going to draw 4 centimeters just to prove And no matter where I swing it, oops, it doesn't touch. I can do it here. It doesn't touch. Do you see what I'm saying? Oh. So what would that be? No triangles possible? Yeah, it doesn't matter where I swing it. I'll never hit A. So this is C equals 4 centimeters. Therefore, no triangle possible. Is there ambiguity? No ambiguity. Okay, we're going to see what sine theta looks like, because you guys are not going to have rulers to draw out every triangle. Like, that's a little ridiculous. You need to use your math. So we're going to do this again. Sine of C, which is 30 degrees, divided by C, which is 4, is equal to sine of B over 10. Does everybody see what I did? I'm going to do a cross multiply over, right? So then I'm going to get sine B is equal to sine of 30 degrees times 10. I'll put dot 10 over 4. And what was sine of 30 degrees again? A half. What's a half times 10? 5. 5 divided by 4. What is that as a decimal, say? 1.25. Remember that little thing that we talked about sine theta? Yeah. Sine theta has to be between 1 and -1. Where does that fall? Outside that domain. Do you see why it's not possible that we got a triangle? Because mathematically speaking, we wouldn't have gotten a triangle. Got it? Okay. Next one. Am I going too fast here? Okay, let's do this again. Again, verify this is 30 degrees. Okay. I am going to extend A again. Oops. Oops. Sometimes okay, I'm extending A. Yes? I'm going to measure B, which is 10. So I'm going to measure this 10 centimeters long, and I'm going to draw it. Oh, I made it too thick. Oh, that's okay. So B equals 10 centimeters again. And then from here, I'm going to measure 6 centimeters. So when I swing 6 centimeters, I didn't actually make my line long enough, but that's okay. Does everybody see I can make a 6 centimeter long triangle by going like that? And like that woman in the video, she swung it even more. Oops. She swung it even more, and she made it like that. So does everybody see how many triangles are possible here? 2 triangles possible. My little c is 6 centimeters here, or we'll call it C1 or C2. My second C is 6 centimeters over here. And some people might not see the triangle, so I'm going to use a different color to show you the 2 triangles, because you might think, oh, there's 3 triangles there. No, we got to use these 2 sides, right? So here is one triangle. Do you see in red? And then I'll show you the other triangle in green. Do you see the 2 triangles? Yeah? Okay. So Is there ambiguity here? Yes, we're not sure which triangle you intend. So, 2 triangles possible. Ambiguous case. Ambiguous case. Okay, and let's look at what our sine theta is equal to. So sine of 30 degrees over 6 is equal to sine of b over 10. I'm going to cross multiply that over, right? So 10 times sine of 30 degrees divided by 6 is what sine b is equal to. And what is sine b equal to? Yeah, 5 over 6. So the big question then is how do you know when you get, what was the first example? 1 triangle, right? My sine b was 3 over 8. And I got 1 triangle. I know when I get no triangle because that's when sine theta is over 1, right? How do I know the difference between when I get 2 triangles and 1 triangle? Well, let's take a notice at this triangle over here. Can anybody measure this right here with their protractor? Can you measure that? Did you get 90 degrees? You get, what did you get? You got 130? What did you get? Give or take a couple. 129? I think when I measured it, I got 130. Or maybe I just used somebody in the class. I got 130. Okay. It's okay. It's not a big deal. So how am I going to get that one versus this one over here? Well, it has to do with, I know we measured this right here, but technically it's B I'm more curious about. So what I want you to do is go back in, even though you measured that big one and you got, I'm just going to make it 130. What did you get for this one here? 20. Okay, so remembering back that I said that when you get sine theta has trig ratios that are positive in quadrant 1 and quadrant 2. So if your reference angle is 20, that would be that angle right there. Does everybody see that? What would my reference angle over there be? Sorry, not reference, but related angle. The reference was 20. So it would be 160. So here's how you're going to be able to tell whether you're going to get 1 or 2. When you obviously can reject that you're going to, the no triangle thing, right? Because it's not bigger than 1. Does everybody see? When you get sine theta equal to 3/8, you know that you can reject the no triangle because you're going to get triangles. You just don't know whether it's 1 or 2 at this point. So it's kind of like one of those logic things. If this happens, you can kind of forget about that. Then if this happens, you can go, now you have 2 possibilities. 2 triangles or 1 triangle. So the 2 triangles that are possible, if there was the case, it would be a 20-degree angle here or a 160-degree angle right here. But what does 160 and 30 add up to? 190. So we're already over 180. So you know for sure now it has to be the 20-degree angle. Got it? Okay, so now if we go to this one over here, I want you to measure B here and here. Can you measure those? Did you get 125 for this one? Yeah. And say 55 for this one? Something close to 125? Okay, but it's pretty close to 125. Okay, so if I were to inverse sine B of 5, 6, my calculator would actually say 55 degrees. Try it. Go on your calculator and find what B is mathematically without measuring. How do I do that? I inverse sine to undo the sine to get B. So it's the inverse sine of 5, 6. And what do we get? Oh, we actually get 56. Okay, so so the problem with measuring by hand, obviously we get off just a little bit. So this is really 56 and then 124. And that's what Raul got, was 124, so good job. Okay, so remembering that sine theta is positive in this quadrant and this quadrant, so if the reference angle is 56 and this is 56, what would this angle right here be? 124? Yeah? Okay, now if you add up 124 and the given 30 degrees, what do you get? 154. So it's possible to have that third angle then. Does everybody see that? Whereas the other one, when we added those two angles up, we were already at 190, so we knew we couldn't have that obtuse angle in there. Do you see what I'm saying? Yes? So, sine law is used when we have AAS, ASA. Tomorrow's lesson is on the cosine law, and that's when we have a side angle side setup or a side 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 setup. When do you only use a sine law? When you have a known pair, or you can get a known pair, right? Yes, but you're right. Okay, so you could have an ambiguous case when you have a donkey theorem setup, right? Two sides and an angle opposite one of the sides. Situation where the given acute angle is opposite the shorter of the two sides. When the given angle is opposite the longer of the two sides, there's no ambiguity. So let's just look at the last example. I did it all mathematically to try to explain it, but some people just memorize this and they get whether there's ambiguity or not. So it's saying the ambiguous case happens when the acute angle is opposite the shorter of the two sides. So if we go back to the two triangles possible, do you see that B was 10 and the one that was opposite the angle C was 6. It was shorter than 10. Do you see? That's when we had two triangles. On case 1, when we had one triangle, do you see B was 6, and this time the side that was opposite the given angle was the longer side. There was only one triangle. I don't really like memorizing it that way. I'd like to understand what's going on, because I think knowing how to get the rest of the angles is how you're going to be solving this anyway, so you might as well just, do it. Okay, the ambiguous case means that with the given information, 0, 1, or 2 triangles could be created. That just means that the ambiguous case is possible. The ambiguity comes when there's actually two triangles, right? Okay, so I'm telling you ahead of time that this is a no solution we're going to solve for B. So we're not going to measure this, you guys. We're just going to do a quick sketch, okay? So A is 30 degrees and B is 6. So we're going to say B is 6. And we need to solve for, I'm just going to draw a triangle. I don't even know if it's a right triangle or what it is. I'm just going to say that this is B and this is C. Does everybody see? And A is 2. Okay, does everybody see that this is a sine law setup? How do I know it's a sine law setup? I have an angle and a side opposite. I have a known pair. That's key for knowing if it's a sine law. Then I have the donkey theorem set up. I have an angle, a side. Do you see that? Potential ambiguous case here. It's set up for it. Okay? So what we're going to do is we're going to solve for B right now. We're going to go sine of 30 degrees over 2 equals sine of B over 6. We do a cross multiply. So sine of B, and you might think that we always use 30 degrees. The only reason I use 30 degrees is I don't need my calculator then, right? Because sine of 30 degrees is a half. It's an easy calculation. You might have sine of 20 degrees or sine of 60 degrees in your problems tonight. Actually, sine of 60 degrees you could figure out too. But sine of 42 degrees, right? So sine B is 6 times sine of 30, what is sine of 30 again? A half. So then a half times 6 is 3. So we get sine B is equal to 3 over 2. And we know that that's 1.5. So that means there is no triangle possible. If you were to use your calculator and inverse sine this at this point, your calculator would scream error, right? Well, it wouldn't scream, but it would say an error, right? Yours screams, that's good. Okay, do we understand the no triangle? Okay, let's do the next one. I already pre-told you what's going to happen until you actually get it, right? Okay, we have this 30 degrees. We have this being A is 3 and B is 6, and this is big B. Does everybody see? So does everybody see? Again, this is set up for sine law because I have a known pair. It's also set up for an ASS, donkey theorem. So we know there's a potential for ambiguity. So we'll set her up. Sine of 30 degrees over 3 is equal to sine of B over 6. Do a quick cross multiply. Sine of B is equal to 6 times sine of 30 degrees over 3. So sine B equals 1. Does anybody know what B is without a calculator? No, sine B equals 1. What does B equal? 90, yes. That's the only place where Y value is. So this is actually should be drawn like this, where this is a 90 degree, and I'm just going to erase that part. Oop. Try that again. There was only one triangle possible. Okay? Example 3. Well, we have 30 degrees here. We have A like this, 3. B like this, 4. And that's all we know. Okay? So sine of 30 degrees over 3 is equal to sine of B over 4. So we get sine of B is equal to 4 times sine of 30 divided by 3. Sine of 30 is a half times 4 is 2. 2 over 3 is 2 over 3. So What can we reject? Yeah, so we can reject the no triangle. There's going to be triangles. This is a donkey setup, so we need to now look to see if it's possible to have, again, if you memorize that, if it's the shorter of the two sides, you know you have two triangles. But I like doing it this way. I'm going to go on my calculator and I'm going to inverse sine B. So what is B equal to? 41 point something. Let's go 42, just to be nice. Okay. Now, that's what the reference angle is, right? 42 degrees. What's another possibility that it could be? What would this angle be? 138. So let's check. Can 138 and 30 add up to less than 180? Yes, so that means we do have two possibilities. So the other possibility is drawing it like this and making, sorry, I'm doing that wrong. I'll try again. I know you used a pen. Like that, because it's this angle that I just solved for. This is 138. B equals 4, A equals 3. And then over here, this was, B was 42 degrees. Does everybody see? 42 degrees. Because that's what I just solved. B was 42. The other B, we're going to call it B2, is 138. Okay? So we created two triangles. We don't know which one we're talking about. That's the ambiguity. One triangle has a 30, a 42, and what's my C angle? What's my C angle? Well, what's 30 and 42? 72? 72 from 180 is? 108. Doesn't look like 108, but that's what it is mathematically. If I add these two together, I get 168. So what's this angle right here? 12. I'm just using the sum of angles. I have to add up to 180 to get the third angle. And then, of course, I can use sine law to find the side lengths that you did for your homework, right? I could finish off this triangle at this point. So do you see? I end up getting two angles for C as a result. Oops, that should be a 1. Okay? Uh-oh, what's going on there? Okay. Example 4. I don't tell you what's going on here. Funny. Okay. Do you guys want to try this and see if you can figure out if there's 0, 1, or 2? So I'm going to draw what it potentially could be. It says solve the entire triangle. That means all three sides, all three angles must be known. Can anybody guess how many triangles you're going to get? 2. The side opposite the acute angle is shorter than that side, so you do have 2. If you memorize that, it's pretty easy. Like I said, but I like doing the math part of it, right? Sine of 36, you can go ahead if you want, is equal to sine of B over 18. So I get sine of B to roughly be 0.8816. So B is approximately 62 degrees. Can you get a second B? Will it work? This is where you see if you can get a second B. And what would that be if there's a second B? Remember, if my reference angle is 62, could I have a 62 degree reference angle in the second quadrant? What would that related angle be? 118. Would that work? Try. 118 and 36, what do we get? 154. So we could get a possibility for C and get what? 154? 26? So if A is still 36 and B1 is 62, then C1 would be 82. 82 degrees, right? Because 36 and 62 and 82 have to add up to 180, and 36 and 118 and 26 have to add up to 180. So the only thing left I need to know is what? Little c. So I'm going to use this setup over here. I'm going to use sine of 36 degrees. Actually, because I'm solving for little c, I'm going to put c on top. So I'm going to have 12 over sine of 36 is equal to little c over sine of 82. And I'm going to do a quick cross multiply. Bada bing, bada boom. What do I get? What do I get? Yeah. C is roughly 20.2. There's no units, so I'll just say 20.2. And if I do it over here, 12 over sine of 36 degrees is equal to C over sine of 26 degrees. You see I'm using 26 instead of 82 this time. What do I get C to be? $8.9? Oh. To recap, this triangle looks like this, right? 36 with an A. B is 62 and C is 82. I'll just put in what I know. B is 18 and A is 12. And then this triangle over here, because I got that there's a second triangle, this A is 36, but this time B we said was 118. That does not look like a 118 degree triangle, so I'll redraw it. Give me a second. It looks like this. Whoops, like that. More like that. That does not look like it either. Let me try it again. Come on. This has to be an obtuse angle, so I think it has to be like that. So A has to be 36, B has to be 118 this time, and C is 26. So again, little b we knew was 18 and little a was 12. We still need to find this little c here. So that's what I did over there when I got 8.9. 8.9.